Alrighty, yesterday we ended here. We just had this one little part left, but I'm going to start back at the beginning so we can get our information back into the calculator or back into Desmos. So scroll back up here and let's go ahead and put this data right here back into Desmos. So I'm going to create my table and have 0 and 3 and 75 and 70.84. So then when I zoom and I do my regression, don't want linear, want logarithmic, we had a problem, right? And our problem, which they remind us of what our problem is here, is that we can only take the log of a positive number. And the only regression for logs that Desmos will give us is a natural log of x or t or whatever it is. Remember that here, this is what it's supposed to look like. So it's t plus 1. If that happens, we have to manipulate this a little bit. And so whatever this plus 1, plus 2, whatever it happens to be and what you are given, that's what you add to your input values here. So since it was t plus 1, I'm going to add 1 there, make that 1, make this one 4. Okay. Then that gave us our A and B right here, which is what we put here. But this equation is not correct because that doesn't say t plus 1, right? Plus we know our actual input of 0 should give me an output of 75. Well, this is 0, this is the y-axis, so that's 0, and clearly I don't have anything here at 75. So what I'm going to do is take this equation, because my A and B's are correct, I export it, and I'm going to go ahead and make this into what I want it to look like, which is actually R of t. So I'm going to back that out. It's going to give me R of t. And then this shouldn't be x, it should be t plus 1. And so now I have the correct form and I have my correct A and B. And I can look at this. Here I have a 0.75. And you can also double check that if I did do, because I know 0 is supposed to give me 75, 3 should give me 70.84. So, oops, if I do R of 3, that should give me my 70.84, which it does. So that's just a little kind of recap of what we did yesterday. I'm going to turn the black function off so that it's not something I'm looking at. The red one is actually the correct one, but I can just leave all that other mess in there, okay? I don't need that either. I can get rid of it or whatever. And then we went and, oops. Then we used our R of whatever to get our slope, right? And then I wanted to talk about this average rate of change a little bit more as well to make sure that we understand what's happening. We're trying to predict the score. So if I look back over here, oh my gosh, you hit the wrong thing. If I zoom out some so I can kind of get an idea of the picture. I mean, this is way up off the x-axis, but that's fine. Well, I'm just going to sketch something that is a decreasing log-looking thing. So if I have this and I've got this decreasing log, it looks something like that, like whatever, right? And if I'm going to, I found my average rate of change from 0 to 3. So, okay, see if I can kind of do that. Oh, this is not great at all. All right, let me try my picture better. That way you can actually understand what the heck I'm trying to say. Okay, let me try that. All right, whatever. That's going to have to work. If I'm trying to do from, I cannot even, y'all, okay. I'm going to have to make it maybe not look very loggy so I can actually show you what I'm trying to freaking show you. We're going to have to do some pretending here, guys. All right. What I'm trying to show you here is that you got this curve. We're going to pretend like it comes down farther like that. Ignore that top blue one because I'm not going to try to erase it. We're going to look at, here we go, this one. I should have made the orange line first, which makes more sense. Okay, so I wrote the equation of a line, and it's this orange line. And I did the rate of change from 0 to 3. So this clearly is 0. This would be 3 right here because it's where it crosses the function itself. And so you can tell by the blue function that rate of change is changing all along here. And so we just found the average between 0 and 3. We are predicting at 4. 4 is past 3, right? So we'll say 4 is like right here. And you see how what I'm finding, what we actually found here, this is the number that's on that orange line. That means that is the prediction. It's not something that's actually on the blue curve because I'm using the linear part to predict that. So since I did that, if we were asked if this is an overestimate or an underestimate, this would totally be an underestimate. But we can't say it's an underestimate because it's below the line or something, or below the curve. You would have to say it's an overestimate because, and remember this orange line, because it intersects at 2 points, that is our secant line, because the secant line is above the curve from 0 to 3 and below the curve for 3 to infinity. Therefore, it is an underestimate. Something like that where you're actually using like bigger words than it's just below it. Right? So that's what we're doing with that estimation there. Sorry that I can't even draw a freaking picture to try and show you. All right, so now let's read this last one. This says, consider the average rates of change of R from t equals 3 to t equals p. And I know stuff like that just blows your little mind because you're like, what the heck is p? Well, it says p is greater than 3. So p is any number that's bigger than 3. Are these average rates of change less than or greater than the average rate of change from 0 to 3 months found in I? Oh, that's weird. It's just, that's in I. It just sort of I-N. In I. Explain your reasoning, and your explanation should include a reference to the graph of R. So again, you can't just say random things. So let me try and draw. My picture doesn't have to be as detailed as the last one. It looks something like this, okay? So from this is 0, this is 3, okay? And then this is p, somewhere that's greater than 3. That's all I know. And it's not even at, so it does say the average rate of change. Are these average rates of change less than or greater than the average rate of change from t equals 0 to t equals 3? So when I found this average rate of change from here to here, right? What happens if I do this? Is it greater than or less than? Okay, something wonky just happened with the video and I'm not starting over. So I have no idea what the last thing that was that came out of my mouth. So let me just kind of start over on this thought. So my average rates of change from 0 to 3 and average rate of change from 3 to p, wherever p is. And I just want to know, are these right here from 3 to p going to be greater than, less than, or greater than the average rates of change from 0 to 3? Well, when we're talking about rates of change with our functions, what should we always write down? Say it loud and proud. I hope somebody actually can. We need our fun chart. So, fun chart. This function, and I know for sure because I can see it over here, this function is concave up. If my function is concave up, my rates of change are increasing along the way. Since my rates of change are increasing, these rates of change have to be more than these rates of change. Hopefully that makes sense. You could also think about it as, if I thought about these little tangent lines, these lines have a negative slope. It's a negative slope that's approaching, kind of flattening out, kind of approaching 0. And if I'm going from negatives and approaching 0, then that also means that I'm increasing. So my explanation should sound something like this. Average rates of change of R from t equals 3 to t equals p, and then I need units on that. That is months, are greater than from t equals 0 to t equals 3 months, because, okay, so that's the answer. It's greater. That's what it asked me for, but then I had to explain my reasoning. That's where I get the because, and I'm not saying it. What is it? R is concave up. Okay. So then we ask ourselves, is R always concave up? Yes, it is. If it wasn't, then I would need to say it's concave up from 0 to p or whatever, but it's always concave up, so I can just leave it there. Then I can say, therefore, rates of change are increasing. Okay, so I had to reference the graph and talk about the concavity, and then the fact that the concavity implies that the rates of change are increasing. There's your explanation. Okay. Now, on your assignment, which you got yesterday as well, there's none of this, these last couple types of questions aren't on there, but they are on what we're going to do on Monday. So the homework is the assignment is kind of basic so that you can just get the basics down. You will have to do on number 5, do some of that solving by hand, but then also use the calculator to get the final decimals, but you can do it, okay? Use your little noggins. And if you finish all this in class, you have plenty of other stuff to be working on that you most likely have not finished and gotten checked. So be good and have a good weekend.